Here's a past paper problem involving forces in pulleys. We've got two objects, A and B. The masses are given as 3 and 5 kilograms, and they are connected by a light inextensible string passing over a smooth light pulley. Object A is on the surface, object B is hanging freely. What we're going to need to do is find the magnitude of the acceleration and the tension in the string. In part B, a little 1 marker, and we need to just state what the effect of a rough pulley instead of a smooth pulley would have on the tension in the string. Pause the video here, and when you're ready, unpause to look at the worked solution. So in part A, what I'm going to do to start is I'm going to label the directions of motion. So the 3 kilogram object is going to be dragged across by the string to the right, and the 5 kilogram object is going to be moving downwards because of its weight. If I label the forces on, I've got tension acting across for the 3 kilogram block. I don't need to include the reaction or the weight here. For the 5 kilogram block, I've got tension acting upwards, and I've got the weight of the 5 kilogram block acting downwards. Now, if I zoom in on both of these, I'm going to produce an equation for both of them. For this first object, I write F equals ma. The only relevant force is tension. The mass is 3 and acceleration is currently unknown. So this is 1/2 of my simultaneous equations right now. If I do the same for the 5 kilogram object, I write F equals ma. Because the direction of motion is downwards, I'm going to consider weight to be positive and tension to be negative, since tensions act in the opposite direction. Don't currently know tension. I do know the mass is 5. I can sub that in. The other thing I can do is I can replace W. That's the weight of the object. The weight can be calculated by multiplying the mass and gravity together. So let's just do that over here. The weight of the object, 5 times 9.8. I believe that is 49 newtons. I can sub that in here. That is my other of my simultaneous equations. I'll take both of these things and I'll write them down next to each other. So I've got t equals 3a, and I've got 49 minus t equals 5a. If I add these together as they are, then what will happen is the tensions will cancel out, since one's positive here and one's negative. So the left hand side will become 49. Right hand side will become 3 plus 5, which is 8a. And if I rearrange this equation, I'll get 49 over 8, leaving me with an acceleration of 6.125 meters per second squared. Now, as with any simultaneous equations, once I've found one variable, I can plug it back into an equation. So I will use the equation t is 3a. I'll replace a with 6.125, and I'll find my tension as 18.375 newtons. Fantastic. So our acceleration is 6.125 and our tension is 18.37. Part B is a quick 1 marker, and it just asks us what would happen if we had to consider a rough pulley. If there's any roughness in the system, then that implies that the tension would not necessarily be the same throughout. The tension in this section might be different to the tension in this section.